Hello guys, welcome back to the channel. So here I want to do only two cases of similar triangles. So by that I hope that the video is going to be extremely short, and by that the two cases of similarity that we have. Let me put this on silent. Yeah, the two cases of similarity that we have are as follows. First, we have angle, angle, angle. Remember, in congruence we have something called side, 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 and if you are able to prove three sides, then you proved congruency. So in similarity we have angle, 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 right? So whenever you can prove angle, 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 you are not proving congruency, you are proving similarity. That's a property for similarity. And another property we are saying it's proportionality. Proportionality, it says corresponding sides are in proportion. So these two examples, they are seen here below with these two questions here, this one and this one. So I'm just going to attempt those two questions and then I'll be done. I want this video to be short, right? So here's the first one. Prove that the following two triangles are similar, right? So for me to be able to do that, I need to find ways for me to do that, right? You cannot assume parallel lines, you cannot assume equal sides, you cannot assume equal angles. Everything that you do, it must have a reason that is valid enough. So here, I'm going to say, start first by identifying the triangle. In triangle AEB, triangle, sorry, and triangle CED, this way. I want to prove that the two triangles are similar. So now I have to, in this case, for me to prove similarity, I don't have sides that are equal. I don't have angles that I know that are equal, except for E1 and E2 by vertically opposite, in which they will not work for me here because it's only those pair that I know that are equal. But one thing I do realize is that this triangle has sides and all the sides have values, right? So for me to be able to prove similarity, I can compare the sides and see if they correspond. So for me to do that, I'm going to say triangle AEB over triangle CED. And by that, what do I want to do? I want to make sure that when I compare the sides, everything that has to do with the triangle of AEB, which is the smaller triangle, I make it the numerator. And everything that has to do with triangle CED, which is the bigger triangle, I make it the denominator right here. If you don't understand that, please rewind it and listen to that again. Now, then I go to the aspects now. You see this side AB. Remember we said everything that has to do with the smaller triangle, I make it the numerator. Anything that has to do with the bigger triangle, I make it the denominator. So because triangles I have three sides, I'm going to do it this way. I'm going to call this side AB. I'm working with the smaller triangles now. I want to mention all sides in the smaller triangle. So I mentioned AB. What other side is there? I have BE. So I'll write BE here. Where is that? I have BE. What other side is there in the smaller triangle? AE. Right? And then I match the sides now. I must find the corresponding sides. Remember the case of similarity, it says corresponding sides are in proportion. So here I have this side that is AB. Which side matches with AB on the bigger triangle? Obviously it's this side, this one. What is that side? DC. Right? And then which side will match this one? BE. Which side will match BE? It's this one that is next to DE, right? So here I'm going to say this is DE. And then which side is going to match AE? Which side is going to match AE? The side that's going to match AE, it's this one. And what is the side? EC. right? And then from there, I start substituting. What is AB? AB is 5. What is DC? DC is 10. What is BE? BE is 3. What is DE? DE is 6. What is AE? AE is 4. What is EC? EC is 8. Now, these two fractions, what they have in common is that when I simplify them, this is what I get. 5 over 10 is the same as what? 1 over 2. 3 over 6 is the same as what? 1 over 2. 4 over 8 is the same as what? 1 over 2. Now, after saying that, you can say, therefore, AEB, triangle AEB, is similar to triangle CED. Why? Because of corresponding sides are in proportion. The reason we are saying corresponding sides are in proportion is because if I compare this side and this side, I'll get the same values. They are in proportion. So if I compare this side over this side, I'll get the same value as me comparing this side over this side. You see that? Hence, I'm getting 1 over 2's everywhere. When I compare AB over DC, I get 1 over 2. When I compare BE over DE, I get 1 over 2. When I compare AE over EC, I get 1 over 2. So even though these sides are from different triangles, but when I compare them together, the sides become in proportion because they give me the same values. You see that? That's how you prove the aspect of corresponding sides are in proportion in terms of similarity. Then the next one, which is this one is the sweetest. So here, what we have, you're supposed to prove similarity again. What you're going to say, first you start by identifying your triangles. We have two triangles here. We have the smaller triangle, which is this one, and then we have the bigger triangle, which is the overall triangle, right? So now, let me remove that. This might confuse us. So now, what is the smaller triangle? It is triangle ADE. Triangle ADE. So in triangle ADE, and what is the bigger triangle? ABC. So I'm going to say triangle ABC. So you first start by mentioning your triangles first. After that, you give me the things that are the same. So unlike in the previous examples, here we don't have values for the sides. So I can't compare the sides because I don't know how much the sides are worth. But then there are things that I have here. For instance, do you see the symbol here? This symbol and this symbol, they are the same. Now, the smaller triangle, I have angle E1. It's equals to which angle in the bigger triangle? It's equals to C. So E1 is equals to angle C. How do I know that? It's given by those symbols we see there. What else do I know? I have this angle D1 here. So D1 in the smaller triangle. Oh guys, what's happening with this thing? So we are saying here that D1, angle D1 is equals to which angle? This angle B in the bigger triangle. So it's equals to angle B in the bigger triangle. How do I know that? Due to these dots that are given, they are showing me that the two angles are equal. So I can say my reason for that is that they are given, right? Now, what else is the same here? Commonly, after you were able to prove two angles that they are the same, you don't have to find the third angle, right? What you're going to say is that in this triangle, you were able to work with angle E, right? Look at that. You spoke about angle E. You also spoke about angle D. You highlight D there. Which angle is left? A, right? So you're going to say angle A is equals to, on this side, we spoke about angle C, right? So highlight C there. We also spoke about angle B, so highlight B there. You're left with what? A, right? So you write angle A there. You don't have to look onto the diagram what's happening. It doesn't matter. As long as you were able to prove the first two angles, the third angles, you don't calculate them. You just say this angle from this triangle is equals to that angle in that triangle. Your reason for that is going to be third angle of a triangle. It works all the time. You prove two angles to be the same. When you have to prove the third angle, you don't stress yourself. You just say this angle is equal to that, because this is the third angle of a triangle. Right? Then you make your conclusion. Therefore, triangle ADE is similar to triangle ABC. What is the case for similarity there? We were able to prove this pair of angle, this pair of angle, and that pair of angles. So it's angle, angle, angle. That's the case of similarity that we have there. So that is all for similarity. We only have proportionality and correspond and angle, angle, angle. So enjoy your day. I hope you'll be fine.